Welcome back, learners. So today we will be discussing a basic design of a typical bioreactor. So it is not any specific bioreactor for specific process. It is a design of typical bioreactor. So, in my last class, I have already discussed that bioreactor is a confinement where an organism is cultivated and motivated to grow, and for that we require various different aspects, and those aspects are your various parameters and various criteria of on which you can design your bioreactor. Okay, so today you can see that this is particular picture which I have embedded in this particular slide, and you know that this particular picture, I will first acknowledge this picture. It is being taken from www.biologydiscussion.com. So I will acknowledge that site for this particular picture, this particular image. Okay, so let's start with the design of bioreactor. So first I will focus on the construction material. So when we are thinking of a bioreactor to be constructed, so what is its construction material? Now, before you know that the bioreactor has been constructed, you have to understand that when we select a construction material for bioreactor, it has to withstand high temperature. So you know that high temperature will sometimes happen. Okay? High temperature, you are constantly adding acid and alkali to optimize the pH. So you know that there is constant addition of acid and alkali. So chemicals are basically produced as well as added into the fermenter. So all these things, and even you know that this is a close confinement, high pressure may also develop. So all these things should not have any impact on the construction material of the bioreactor. So that is the basic criteria while selecting the construction material, and depending on the construction type or the bioreactor vessel, it is either made up of only steel, which is your stainless steel. Okay, it can either made up of only steel or only glass or steel and glass combination. Okay, so only steel or only glass or steel and glass combination. Okay, so glass is used to construct a small scale bioreactor, right, of 1 to 30 liters of capacity. And you know that this particular stainless steel which I am talking about, right, it is, the glass should be, first of all I will talk about the glass. The glass should be made up of 100% borosilicate. Whereas the stainless steel, this should be used of the brand, a widespread brand of the stainless steel, that is your 316L. So what is this 316L? The L indicates that the steel is with low composition of carbon. So the steel is with low composition of carbon. Okay. So this is about your construction material. So your construction material is made up of your stainless steel and glass. Now, small scale bioreactors are basically of two types. So moving on to the small scale bioreactor, it is also a part of your construction material, and depending upon it, there are two different types of bioreactor which I will be highlighting, and that is, one is your glass vessel. Okay, so if I talk of your glass vessel, it is completely made up of glass with either flat or round bottom. Okay, so it is made up of complete glass with flat or round bottom, and sterilization is basically carried out by autoclaving. Then comes another aspect, that is your glass cylinder. And when I am talking of your glass cylinder, in this type, the cylinder part is made up of glass, the top and the bottoms are made up of your stainless steel. So the top portion is made up of your glass. and the bottom is made up of your stainless steel. Okay, so the large scale bioreactor are completely made up of stainless steelized steel containing of more than 4% chromium. In addition to the chromium, they contain some amount of nickel and molybdenum. Okay, they form a hydrous oxide coat on the surface. Try to understand that the stainless steel forms a hydrous oxide coat over the surface which is non-porous. So this coat is basically non-porous, smooth and insoluble. Okay, so these are the criteria, and the commonly used stainless steel is AISI 316, which contain 18% chromium, 10% nickel. So if I write down 10% nickel, 18% chromium, okay, 2 to 2.5% molybdenum. Okay, so as the size of the bioreactor increases, the thickness is also increased. So this is about the construction material of your bioreactor. Now I will move on to another aspect of bioreactor. So before I move on, so let me tell you that that if you don't seal your bioreactor, if you don't make it airtight, what will happen? From the very beginning, I am saying that if some contaminating microbes are getting into your bioreactor, what will be happening? It will lead to development of so many other obnoxious byproduct. That means it becomes very difficult for you to take out that particular product which you require. So that is why seal, that means sealing the fermenter, confinement is very important. So I will basically highlight, I will highlight this particular seal. See, this particular seal, sterile seal. So with this respect, I will discuss about your aseptic sealing of your biofermenter. Aseptic sealing of your biofermenter. One of the major quality comparative characteristics of different bioreactors is its ability to secure sterile fermentation. So sterile fermentation is desired. That is most important desired criteria. Aseptic sealing is used in order to prevent contamination. So there are three types of aseptic sealing. One is your glass sealing. Next is your glass metal sealing. Third is your metal sealing. So you may have glass sealing, you may have a glass metal interface, you may have a metal interface. Okay, so methods of sealing basically comprising of your compressible gasket, lip sealing and your O-rings. So most of the fermenter usually have your O-rings. So you have a O-ring. So you get to see a round ring, O-ring. So in case of metal sealing, only O-rings are used. For the other two types, any of the three methods can be used. And O-rings are one of the most common seal used in bioreactor design because they are inexpensive. So these O-rings are inexpensive. Okay. Easy to make, reliable. So easy making, reliable. Okay. So that is why most and simple mounting requirement. It is being mounted in a very simple fashion, right? So that is why aseptic sealing is usually done with the help of your O-ring. Now we will move on to your another aspect. So that is very important, and I have talked about your aerobic and anaerobic respiration, and that there comes the importance of your aeration and agitation. So I will discuss over here aeration and your agitation. Okay. Now, when I'm talking of your aeration and agitation, first we will go one by one. Aeration. What is your aeration? Aeration is the entry of your oxygen into the vessel. And that particular air, the first criteria is that the particular air has to be your sterile. So for that, you have a part in your bioreactor, a fermenter, and that is your Sparger. So you have your Sparger. So before I move on to the Sparger, let's take some images of your Sparger. Okay, that what type of Sparger, what is the design of a Sparger which can be introduced into the vessel. So if I keep these two side by side, first and foremost thing is that this is the sterile air, and you get to see in this diagram that this is the Sparger. And here you get to see that there are three different Spargers in front of you. One is your jet nozzle type Sparger, another is your diffuser type Sparger, another is your perforated plate type Sparger. Okay. Now the question is that why this type of design? See, this design is a nozzle based design, and you get to see that the air is moving inside with high pressure. So what is the reason behind the air moving inside with a high pressure? The first reason, when you are incorporating air with a high pressure, you get to see that there is a high pressure zone at the bottom where the air is entering. And on the other hand, at the top of the fermenter, there is a low pressure zone. So what will happen? The air will move from the high pressure zone to the low pressure zone until the pressure equalizes. And when the air will move more and more to the low pressure zone, the density of the air will be higher at the top. So what will happen? Again, according to the density, the air will move down from higher density to lower density. So like this way, there will be a constant circulation in the fermenter. And that is very desirable to distribute your oxygen throughout the vessel. And that is why we are incorporating using a Sparger. Moreover, Sparger is also allowing the air at a very high pressure to enter inside the vessel. So when it is allowing it, that high pressure will also enhance the solubility of the gas molecule. So it will also enhance the solubility. So solubility is enhanced, as well as there is a partial or there is a development of circulatory motion in the particular fermenter, right? Apart from it, there are other two fermenters, other two Sparger, which are being discussed over here. That is your gas Sparger, that is a diffuser type and perforated plate Sparger. That they are used in the bubble column bioreactor, which I will be discussing later. So in a base plate, you will have multiple different pores. So here, the main reason is that, a stream of your air is basically introduced into the fermenter. You will have bubbles of air into the fermenter, a jet of air into the fermenter, and that particular air will be thoroughly diffused by this particular design. Its main aim is to diffuse the air throughout the fermenter, okay? To form a jet of air, or column of air in the fermenter. So that is why we have different designs of your Sparger. So one is a nozzle-based Sparger, another is a diffuse type Sparger which will diffuse the air, another is perforated plate. In the base plate, you will have multiple different perforations through which the air enters. Okay? And moreover, the air which will enter has to be sterile air. And for that, there has to be some filters over here, and that is your membrane filter. I will not talk about only membrane filter. There are many different kinds of filter. One is your membrane filter, packed bed filter, and your cartridge filter. So with this, I will end the class. I will end this particular portion today. That means in this particular class, we have discussed about the basic construction material of the biofermenter, its sealing process, and the aeration process. So from the next class, we will move on to the agitation process. Thank you. Thank you once again.